actually consider how they are made or how they work. A single lever mixer tap begins life as a bucket of very fine quartz sand. It's forced into heated molds and then baked at 260 degrees Celsius. When it's hardened, the sand has been transformed into a mold itself. Once they've smoothed off the edges, it can be used to cast the taps. Meanwhile, recycled brass parts have been melted into a huge 2.5-ton furnace at 1050 degrees Celsius. They place the molds into a low-pressure casting machine and blow away any loose grains with an air gun. As the liquid brass is poured in, the duct is heated with a blowtorch to keep it flowing smoothly. 2 minutes later, a couple of pairs of taps drop out. They need to get rid of the solid sand inside the taps, so they blast them with ultrasonic sound waves to break it down into grains. The taps have been created as co-joined twins, but they are easily separated by a metal saw. Each tap can now be drilled, countersunk and cut. This large machine contains 17 different tools and does all of the jobs single-handedly. Each opening and thread is carefully checked. If any of the taps aren't up to scratch, they get melted down and remolded. For those that pass, it's time to get scrubbed up. First, a robot smooths out any rough edges by rubbing them on sandpaper. Then it polishes the surface with pure cotton. The brass body is finished. Another robot displays every angle to a camera lens, which checks it's perfect. This one is faulty, so it's put to one side for inspection. A human has the final say, and the quality controller confirms the robot's findings. It's rejected and will be recycled. For the lucky survivors, it's time to take a dip. A computerized system guides them on a route through several troughs. First, a rinse removes any dirt or grease. Then they get dunked in nickel. It forms a silvery coating which helps to protect them from corrosion. Finally, they're immersed in a chrome bath for 4 minutes. Beneath the bubbling surface, the taps are receiving a final coating that will help them last a lifetime. An electrical current sets the taps to a negative polarity and the chrome bath to positive. This causes the taps to attract tiny chrome particles from the water and creates a fine surface layer of chrome that's thinner than a human hair. While the bodies are drying, the heart of the mixer tap is put together. The simple mechanism is what makes the tap so efficient and environmentally friendly. Turning the handle moves an element with an oval opening inside the tap. To the left opens the waterway to the hot water pipe, in the center to both hot and cold, and moving it to the right closes the hot water flow so just cold water flows out. Mixer taps with spray mechanisms like this can save up to 80% of the water used by standard pillar taps, as they produce a steadier flow with less water pressure. Once the mechanism is put inside the tap, a final test ensures that the water flows out smoothly. They've been polished by robots, coated with nickel and chrome, and their inner workings will help to conserve the world's water supply. Maybe this humble tap is not so humble after all.